we're going to look at factor form of quadratic. If we're given some of the values, and then we're going to work through how we could find other key points of a quadratic. So what we've been given is a general formula for the factor form of a quadratic. So in other words, we have a y and an x because essentially a quadratic is the relationship between these two variables, an independent one. And then r and s are telling us roots. And this is our factor form. It looks like a term times a term, and there could be some a term involved also. On the side, they've pretty much just given us what our values are. They've told us that a is equal to 1/2. So we're going to replace a with 1/2. They've told us that our r value here is 2. So we're going to replace our r value with the number 2. And then they've told us that our s value is -4. So technically this says subtract, I'm going to put it in a small bracket here, -4, just so the notation's a little clearer. So what we've done is essentially just plugged our values in. We've been given our factor form. That's really easy. That part's simple. We're going to simplify it a little. And the only part I'm really going to simplify is this bracket here because we have two operators beside each other. But if we were asked to put this into factored form, our negative, you're subtracting a negative value is the same as just adding it. So there's our simplified version. That's our factored form. What's important about factor form and what they've actually given us on the side here is if we were to graph something like this, we've been given roots. So I'm going to make a little rough sketch on the right here because we're going to do some more algebra on the left. But what they've given us is one of the values are equal to 2. That is essentially means that one of the roots, am I using the right value here? Yeah. One of the roots here is at 2 and 0. So it's going to cross the x-intercept at 2 and 0. Our other root, which is the s value, is at -4. So we have a value here at -4 and 0. Okay, that's good to know. Our a value has to deal with something called the stretch and our compression, which we probably haven't talked about much yet, so we won't focus on that PCI. But we have two key points if we want to graph this. Now, the question starts to become, well, how does the rest of this parabola look? Does it swoop down like that? Or is it actually facing the other way? We're not quite sure yet. There is something I could look at. Technically, it depends on my a value. And because my a value is positive, it does open up like that. But let's say we haven't been given that information yet. We're not aware of that. A -1 faces down. We're not aware. What we're going to do is we're going to try to find out some other key points. So we have our two roots. And if you have two roots, you can start to find what they call an optimal value. Okay? Optimal value, which is also known as a vertex. So if we have our two roots, we can find the x value of the vertex because we're looking for the number that is directly between the two of them. So we call this an axis of symmetry. Okay, axis. And they sometimes call it an AOS. Okay, symmetry. I think that's it. There's a formula for it, and essentially what it is you take one of the roots, so you take an x, we'll call it x1 in this case, plus x2, and you divide by 2. For all intents and purposes, what you're doing is you're finding the average between these two values. Okay, and so if you find an average between anything, you add them together and divide by the number of values there are. The average between them will be the direct middle of this quadratic. And what's nice about this is they've been given the roots, so we're going to go ahead and carry this piece out. If we're trying to find the axis of symmetry, which is like a line that runs right through the middle of it, our r and our s values from above are these values. So one of them happened to be the number 2, and the other one happened to be 4. So we're going to add -4, and then we divide them by 2. This will give us -2 over 2, which is -1. So visually in a graph, what does that mean? That means at -1, which is about here, there is a line of symmetry right through this parabola. So if we were to draw it once again, that means the optimal value or the vertex is right at that point. Our only downside right now is we're not quite sure which way this parabola is going, up or down. But we can still solve that piece. This is essentially the x value of the vertex is at -1, okay? What we don't know is the y value. So we can say for our vertex, we have -1 and some y value that we're unsure of yet. Well, if we have an x value, we can plug into our equation. So we're going to go look right back up to this equation here. I'm going to gather it. Y is equal to 1/2 x minus 2 x plus 4. I'm going to take that x value at -1 and I'm going to plug it in for both of the x's. That will help us find what the y value of the vertex is. So let's plug this in. Y is equal to 1/2 -1 minus 2 -1 plus 4. Okay, so we're using that equation in factor form to solve this other piece. We carry out some of the algebra here. We get -3 and 3, which is going to give us 9, or -9, I should say. And we're going to get -9/2, which is equal to -4.5 as a y value. So in other words, our coordinate, -4.5, or if you like, prefer the fraction, is there. And what that tells us is, well, the x value is along this red line I've drawn. The y value is at -4.5. So let's say we're going down by 2. 2, 4, that's probably about there. That is our coordinate. And what's great about that is just told us which way this parabola is opening. The optimal value, or the vertex, is this that we just found. And we did that all using factored form. The only other key piece that we've kind of left off here is a y-intercept. And we can visually see it's there-ish. What that exact value is, we're not 100% sure, but that's a really simple thing to find with any equation. If you're looking for a y-intercept, okay, so your exactly, a y-intercept is when x is equal to 0. So the exact same process we did here with x is equal to -1 for the optimal value, or the vertex, we repeat it in the exact same equation we're given, but instead of -1, like we had just previously done, we use 0. So we get 1/2, -2, and 4. That gives us -8/2, which is -4. Excellent. Now that's actually a really easy one. So in other words, we were crossing at this point at -4 right on the dot, okay? So in terms of graphing a parabola, using this factored form, okay, we were able to figure out the vertex. We were able to the roots, or the x-intercepts, which are really simple to see because they're in factored form, and the y-intercept, which would be 1, 2, 3, 4 major points of a parabola. We've essentially solved all of them just using that factored form.